So what I want to do today is just wrap up sort of what does that actually mean for us, and what does that mean for us as dairy farmers as well, and then finish off with a bit of what we're sort of doing. So obviously Milena talked about the Kyoto and Paris agreements, and what they actually said and what we agreed to as a national determined contribution is in the Kyoto Protocol a 5% reduction below 1990 levels by 2020. So we're in the second commitment period of that, which is 2012 to 2020, and we're on track to meet that target, and that's mainly through afforestation and offsetting. But then, because there was a new agreement signed in 2016, the Paris Agreement, that put a different baseline on it. So that talks about a 30% reduction below 2005 levels by 2030. And the commitment period's from 2021 to 2030. So if you convert that back to 1990 levels and the different baseline, it's about 11% below. So as Milena said, each agreement's intended to be more ambitious, and this is. It's just doing it from a different baseline. So it's still trying to address the same thing. So how do we actually calculate emissions? And it's important to note that the way the sectors and how we account emissions nationally is determined by that UNFCCC, so that every country has similar sort of categories and what's in them. The devil in the detail about how we actually calculate within each of those sectors is where MPI does a lot of work. And some of this way we calculate is very world leading, and it's quite scientifically based compared to a lot of other countries. So we have to understand that it's very complicated, but in terms of compared to other countries, we do a hell of a lot more work into accurately trying to establish this than other countries. So there's 5 main sectors. So the first one's energy, which covers transport. Okay, and this is for 2016, the last reported year. There's IPPU, so industrial processes and product use. So for Fonterra or milk supply companies, that's where the energy use sits in for actually processing some of your milk as well. There's the agriculture, which is a big sector for us, and I'll go into that a bit later on. And then there's the waste sector. So there were some questions about where does methane also come from? Methane from landfills is the other big component of methane, and that comes under that waste sector, so it's calculated differently. Now all those, so that's our gross emissions. Our gross emissions in 2016 was about 79 million tonnes of CO2 equivalents. So the global warming potential that Milena was talking about converted back. And then we've got this green box at the end called LULUCF, land use change and forestry. And that's actually a reduction, and that's through all our afforestation, and that sequesters or removes carbon dioxide from the atmosphere at about 23 million tonnes a year at the moment. So that leaves us with net emissions about 56 million tonnes. Okay? And it's important to know that all these other sectors, they actually do, apart from agriculture, they actually, and the ETS will be covered a bit later on, they actually do pay for their carbon emissions one way or another, generally through fuel taxes and other taxes. So what does that look like over timeline if we look back to 1990? So 1990 here, this is our gross emissions and our net emissions. 1990 we've risen about 20%. Since then we have, if you can see, flattened off quite a bit since about 2005. But our net emissions have also climbed. And what that actually means is we've removed some of our sequestering ability or removed forests. So that has increased, and it looks like a total difference of about 29% now, and our net emissions have increased about 54%. So that's how it's currently looking for us tracking over time. What does that actually mean for our profile? So we have quite a unique profile in the ways, and because it's accounted at that international level, UNFCCC, this is why methane and agriculture emissions are, I wouldn't say a problem, there's a need and understanding that we have to understand them a bit better, I guess. So we've got about 43% of our national profile sitting in methane and about 45% in carbon dioxide. So there's been quite a bit of change since 1990. Agriculture, so the 5 main sectors that it's broken down to, agriculture has increased by about 12%. Waste has actually decreased. The energy/transport sector has increased by 32%. Industry, so IPPU, by about 35%. And land use change and forestry has increased by about 23%, which means we've removed some trees. So it's interesting to note that for a developed country, because the international agreements separate developed and non-developed countries. For a developed country, we have a very unique profile with that quite a lot in agriculture, because we have in comparison, quite a small energy sector. We have a lot of renewable energy, and that's why our agricultural sector looks larger. The only other country that has even closely similar to profile like this to us is Ireland, which has got about 14% of agricultural emissions, and we're sitting at about 48%. And so we're quite unique in this area. So MFE took the way that we account, and they did some projections back in 2015 about what it would look like if we carried on our current trend out to 2030. And basically, non-surprising, everything increases a wee bit. But what that actually means for our reduction or a national determined contribution by 2030, that Paris Agreement, 30% below 2005 levels, is we have to try and sequester about 25 million tonnes of CO2 a year by the 2030. So that's the target we were trying to get to. But it's important to also understand that for the agriculture industry, we have become more efficient. So on the left here, kilograms of CO2 equivalents per kilogram of milk solids or meat. So the top line's the sheep, the red line is actually the beef, and the blue line below is the dairy. And it's not hard to think why we've become more efficient. And we've actually become about 50% more efficient for our industry over that time. And it's because of better pasture management principles, better pasture species, and better improved genetic merit in terms of improving the BW of our herds. So they've all become more efficient at turning pasture, better quality pasture and better management practices into meat or product, and therefore less per kilogram of CO2 equivalent emissions. So usually, if we look over that timeline, we have agriculture has increased by, remember back a couple of slides, we've increased by about 19.2% over that time. But actually, if we didn't make those improvements, we would have increased by about 40%. So we've become 50% more efficient since 1990 is effectively what that's saying. And that is understood by the government. So what does this actually mean for the dairy industry? Okay, so here's our profile. Agriculture makes up about 49.2 based on that international way of accounting. 49.2 of New Zealand's emissions, so this is agriculture, the blue line here, and it's broken down there, I hope you can see in your handouts. Dairy farming makes up 40, so dairy cattle here, makes up about 46.5% of the agriculture emissions, and what that means is dairy is 22.9% of our total emissions, so we're about quarter, which is why the way we count and everything and the methane production is actually quite important for us. And it's interesting to note that when they're looking at that graph just before, that's talking about this 85 percentile mark. So there are other parts of our industry that actually, and the manufacturing and transport of our products overseas as an exporting nation, that are captured under other sectors. But they already are captured under the ETS framework. But if we really want to affect change, we have to actually think about what we can do on farm as well. So I'm going to talk a wee bit about how methane's produced, but this is really going into some of Cecile's stuff. And the key thing I want to note out of this is about 80% of those biological emissions come in the form of methane. So a cow eats and masticates her food, spits her cut up and chews it again, breaking down the plant in the rumen, and the byproduct from that is methane, CH4. About 95% comes out from her burping, and then there's some hindcut fermentation that happens, and she has about 5% in flatus and dung and urine. So most of it is from 80% of our emissions is biological, is from methane, and that comes out the front end of the cow. And many of you will be aware of the nitrogen cycle, and so what happens is under cows urinating and the high nitrate levels going into the soil from her urine spots, that actually nitrifies to nitrate and sits there, and then when you have a drainage event, that's when you get nitrogen loss below the root zone. However, in that soil pool of nitrogen, if it gets under the right conditions, particularly warm, wet, anaerobic conditions, it actually denitrifies to nitrous oxide. So that's where we get our nitrous oxide emissions to atmosphere. And Cecile will cover the depth of that a wee bit later on, but this is about 20% of our emissions. So 80% methane, 20% nitrous oxide. So keep that in mind. So obviously if you've got a soil pool of nitrogen, it's going up or down one way or the other. And then the carbon cycle. And this is, so for the carbon cycle, for how they calculate it, remember that this is also agreed at an international level. So what it's assumed is that the carbon cycle is a net balance, which means everything that is sequestered by plants is then eaten by cows and expired in terms of respiration, CO2 respiration as a living animal, or turned into milk and meat, and then we eat that and then produce CO2 from that. So that's assumed a net balance. The way methane's calculated is because actually within the gut the methanogens convert hydrogen and CO2 to methane, the warming potential of that sits outside the carbon cycle. So the accounting for that under GWP 100 is why we have such a big methane component of our biological emissions. So that's the way that it's calculated internationally. And eventually that does break down over that residence time that Milena talked about to CO2 and is back into the cycle. But the warming potential while it sits as methane is why our emissions look the way they do. So what we did last year as one of our actions under the Dairy Action for Climate Change is we have a program many of you might be aware of called Baseline Project within DairyNZ. It's got about 450 farms as part of it, and they've got some quite detailed records in terms of financial and physical records. And we took that baseline project and looked at, through Overseer, what the greenhouse gas emissions would look like from those baseline files, and there enough detail in them to try and accurately, as much as we can accurately, represent what our emissions actually look like. So total greenhouse gas emissions per hectare, so think about that per every hectare, the mean came back at about 11.22. Now, within Overseer, this is also calculated a wee bit of carbon dioxide, and that's generally from your cultivation activity within the model. So it's a bit higher than our true biological emissions. You could take about another 1 tonne off that, so our average is about 10.5 tonnes of biological emissions per hectare. So it starts, when you start adding up, times it by hectares, starts adding up to quite a large amount, and that's every year. So we also broke that down a number of different ways, and we do have that report online, I think. And we looked at it by region as well. So Lower North Island, lower emissions for our baseline files that we've got here. Canterbury a bit higher and Waikato a bit higher. Generally, the more intensive system, the more dry matter, kilograms of dry matter that you put into the cow, you'll have more of a methane emission, and then that is generally the intensity is what makes of the system is what makes that higher emissions. So some regions are a bit lower than others, but the calculation generally in our national inventory and within Overseer is for every kilogram of dry matter that we eat, it goes down our cows' throats, it's about 21 grams of methane. Okay, and so what does this actually mean for our dairy industry? So NIWA did a really good report on their website in 2015 and basically looked at if we continue on our rate of warming, what does that actually mean for us farming? Because it's going to have potential effects on the way we grow grass, the species that we can use, and the fact that we're probably going to be in drought a bit more and have more extreme weather events. So that's kind of what the whole report actually said. More extreme weather events, flooding, droughts, etc. Changes in water availability, particularly if you're in surface take situations. Increased risks of pests and diseases, and there's going to be some increased commodity market volatility. So obviously, with our trade winds being more westerly, the west side of the country is going to have warmer days, a warmer average temperature, and more what they call hot days, which is days over a 25-degree average. So what does that actually really mean? We're going to have more days over that 25-degree average, so heat stress for our cows, some of that fungal disease or risks of pests in our cows. Increased growing days is an interesting one because basically we're going to have, for those colder regions, we're going to have probably grow more dry matter, but until we get to those really hot days, and then we're in drought a bit more. So weed establishment, pasture performance, more dry days than normal per year. So what does water look like, availability and storage, fire events, pasture renewal, erosion of prone land through more extreme rainfall and more westerly weather. So that's going to, the things around trees on farm and shelter belts are going to have a more increased importance for us as dairy farmers, and longer and more severe droughts. So timing of farm decisions is quite important as well, particularly around management. So what have we done? So as John Hayward and Jim Vanderpoel talked earlier on, we've done a number of things over a number of years that led us into the Dairy Action for Climate Change. But I just wanted to start off with about that in this area where there is a lot of collaboration. So a lot of acronyms coming at you, NZAGRC and PGGRC. So New Zealand Agricultural Greenhouse Gas Research Centre looks at funding a lot of the science that we're doing and asking a lot of those questions. The Pastoral Greenhouse Gas Research Centre is another component. So this is MPI funded. This is industry and MBIE funded. And what the PGGRC is actually does a lot of that detailed science here in the Manawatu at Grasslands next to Massey, AgResearch, and they've got a methane research centre there as well, which is pretty world leading. The other thing we've done the last couple of years is we, along with government, have set up, as in DairyNZ, have set up the Biological Emissions Reference Group, and we invited a lot of other partners to be part of that, and that's looking at really what we can do currently and in the future to address our biological emissions, and trying to put some scientific evidence around that, so we're not, so that we're all on the same agreement about what can be done, and it's not people quoting different things left, right, and centre. So that's still ongoing. There's a report due to come out from that, and in the next wee while, basically looking at what we can do now and in the future, and what are some of the costs and risks around that. So there's a question about what are these going to cost. That's coming out shortly. Okay. So the Dairy Action for Climate Change, as John talked about, what we did was we put this together last year, and was signed by the then Minister of Climate Change, Minister Bennett, into the National Party, and launched at last year's Field Day. So we're a year into this, and what it's really trying to do is address farm dairy greenhouse gases in the context of a profitable and sustainable dairy industry. So what does that affect on our industry's profitability and production actually look like? So we broke it down into three parts. The first part is what we call building the foundation, and that's where this workshop sits under. It's about building understanding and having the discussion. And we started last September with some rural professional roadshows, and we had about 450 attend over 9 workshops throughout the country. Really good feedback, and that led us into the second part, which is through previous programs of work, Primary Growth Partnership, we actually set up a Massey greenhouse gas course, similar to intermediate nutrient management, looking at a lot more detail of what we're showing you today. And we committed to putting 60 rural professionals through that course, and we had a pilot in May last year. We had the first 2 commercial courses which we funded were in December last year and just been May this year. And so from those 450 attendees, we asked for invites on who would want to go on this course. I think we got about 250 people wanting to go on it. We could only afford 60, so we put them through in these, and we completed that to try and build awareness in rural professionals, so that then when they have conversations with you as farmers, they understood what they were talking about as well. We also earlier this year had a number of events with our Dairy Environment Leader Group, about 9 events throughout the country, in which we asked them to give them a bit of context in the background, but also we wanted their help in the formation of our position around this. So they had a lot of input into that, and from those workshops, we also asked for expressions of interest in what we called our climate change ambassadors, which are farmer representatives that can talk to the media and understand what's going on and help influence DairyNZ's position as well. So those ambassadors spent a couple of days in Wellington recently doing some training and in-depth understanding with scientists about what's going on, and were able to answer those questions so that they could then look at being dairy industry representatives, not DairyNZ representatives, dairy industry representatives. So that's and the last component of that building the foundation is this component, which is we've got 8 workshops throughout the country looking at predominantly trying to be farmer facing to help understand and educate and realise that this is a journey. This is not going to be solved in 1 year, and that there is a commitment for us to continually come back and do this so that we keep building the awareness and building knowledge. The second component, and you've heard a bit about it, is what we call steps to lower emissions dairy industry. And that's about the partnership farms. So what I'm currently setting up, and we've set up 15 because there's another number of other projects involved, but it can be the milestone, or what we're trying to do is get down to a few less than that. But what we're looking at is real case studies of farms and establishing where they are at now in a baseline with Overseer and Farmex, and then modelling what change would look like going forward if they had to reduce their nitrate loss and greenhouse gas emissions. And what would be the effect on productivity and profitability, because the water quality and the greenhouse gas emissions are quite intertwined in terms of their mitigations. And Cecile will go into that a bit later on. So, important things to note about the project in terms of what we're trying to achieve. We want to demonstrate the feasibility and practicality of implementing these mitigation strategies for greenhouse gas emissions and nitrate leaching. There's a question about have we looked at other options around alternative systems. We tried to, once you try to get people involved in a project like this, we did look at different farm systems. We didn't go to the full breadth, but we tried to keep them as owner-operated real farms from System 1 to System 5. And the reason we did that is we wanted to be able to extend to a wide audience and not. So there is potential to look at other systems, but currently we're just kind of look at normal owner-operated dairy farms. And then to demonstrate what those reductions would look like on farm and quantify the effect on production and profitability. The cost thing that we're trying to establish and what does this cost in industry is very important. To ground truth the farm system changes, if in a theoretical world you click your finger and the farm system changes. That's not quite true in the real world. The real world says that management change around that takes some time, and it takes time to get it right as well. And there's a component around this, around education ongoing, and what's the implication of these changes for the wider sectors and community. So the third part of the Dairy Action Climate Change, which actually isn't our part, it's Fonterra's part, and they're just about to finish that off now. And what they did is they took 100 of their farmers from their nitrogen reporting pages and looked at their greenhouse gas profile and what information they would need to understand that greenhouse gas profile, and they compared that to the national inventory methodology and a life cycle assessment. So that report's coming out fairly shortly as well. And then what we're trying to do currently is look at what the next stages of the Dairy Action Climate Change would look like, and if we could, through milk supply companies, look at being able to provide farmers through their nitrogen reporting for the Sustainable Dairying Water Accord, what that would look like in terms of greenhouse gas profile. So farmers started to understand what their profile actually looked like for their Pacific dairy farm. So that's about it. That's what we've been doing for the last year.